For lesson 1.1 in trigonometry, this is part 4. This is a very long lesson laying the groundwork of trigonometry. And this last part of the lesson, part 4, we'll be talking about linear and angular speed. So when something moves in a path of a circle, there's a couple of different things we want to consider. We want to talk about the motion of a particle, or if you think about a merry-go-round, if you're thinking about a particular horse and its distance around the merry-go-round, there is a distance, there's an angular, there's a speed that is not linear, so it's something we want to think about. So this says a carousel contains 4 circular rows of horses. So there'll be some on the inside row, middle row, and then lastly there's an outer row of horses. And you can imagine a horse in the outer row is going to travel a further distance around the circle than the horse on the inside row. It has a smaller circle to cover. So their distances are different. Their speeds are different. Maybe not. So let's see what this says. A carousel contains 4 circular rows of horses. As the carousel revolves, the horses in the outer row travel a greater distance per unit of time than those in the inner rows. The horses have a greater linear speed than those on the inner rows. However, all the horses, regardless of the row, complete the same number of revolutions per unit of time. All the horses in the 4 circular rows travel at the same angular speed. Okay, so let's define these terms, linear speed and angular speed. So on the last page of the notes, the definition of linear speed: if a point is in motion on a circle of radius r through an angle theta, now that angle has to be in radians again, not degrees. In time will be t, then the linear speed is v equals s over t. So in physics, the v is velocity. So this is the speed equals s, which is our arc length, divided by time. S is arc length. And that comes from the formula s equals r theta. And its angular speed is omega. This is our lowercase omega equals theta over t. So the angular, that's a formula for angular speed, or a symbol for angular. So the linear speed, now this is supposed to be a v, looks like a little gamma. V is a point, a distance r from the center of the rotation, that's given by v equals r omega, where omega is the angular speed. So if we want to find linear speed, we've got to know what the angular speed is, this omega, and multiply it by the radius. Okay? So let's put these formulas to work in these example problems. So this says, long before iPods that held thousands of songs and played them with superb audio quality, individual songs were delivered on 45 RPM and 75 and 45 RPM circular records. A 45 RPM record has an angular speed of 45 revolutions per minute. That's what RPM means, revolutions per minute. Find the linear speed in inches per minute at the point where the needle is 1.5 inches from the record center. Okay, that's my radius, 1.5 inches. And they tell me that 45 RPMs is the angular speed. So that's our omega, 45 revolutions per minute. And we are supposed to find the linear speed. The linear speed is v in inches per minute. Okay, so if we know that we're looking for the angular speed formula, v equals radius r times omega, which is the angular speed, and this is our angular speed, but the problem is our units. You see, if I plug in 1.5 inches for the radius, and I plug in 45 revolutions per minute, I have a problem with my units. My answer is supposed to be inches per minute, and I need my revolutions to cancel out, you see, because I need inches, not inches times revolutions over a minute. So I need to come over here. Remember they said the angular speed omega was 45 revolutions per minute. It's a rev r. I need to multiply this by 1. Let's see. I need my revolutions to cancel. 1 revolution is 2 pi radians, right? That's a distance in a decimal, if you will. So I'm going to multiply these two fractions, 45 revolutions times 2 pi over 1 minute times 1 revolution. So my revolutions cancel, and I get 90 pi over 1 minute. 90 pi radians. I'll just put a little R. 90 pi radians over 1 minute. So that's what I'm going to replace. My radius is staying the same. I'm replacing omega with 90 pi over 1 minute. And so when I multiply this up, I'm going to get inches per minute, you see. And that was my units that I needed to find. So when I multiply 90 pi times 1.5, that's 135 pi inches per minute. And then to get a decimal, let's go plug that in. I could go back and check that. 1.5 times 90 pi over, oh, just 1. 424, I'll just round to the nearest unit here, inches per minute is my linear speed. And that was the question. Find the linear speed in inches per minute. So, what a messy problem. It's about as hard as they get. Okay. All right, let's try another one here. A 45 RPM record has an angular speed of 45 revolutions per minute. So that's the same as what we just read. Find the linear speed in inches per minute at a point where the needle is 1.5 from the record center. That's the same problem. Well, there we go. It's the same problem. This was 1.5. There's nothing different there. So, same answer, same problem. Sorry about that. Okay, let's go to the Ferris wheel problem. You're riding on a Ferris wheel and wondering how fast you're traveling. Before you got on the ride, the operator told you that the wheel completes 2 full revolutions every minute. Okay, 2 revolutions per minute. That sounds familiar to what we did up here. And that your seat is 25 feet from the center of the wheel. That means the radius is 25 feet, right? And it wants me to, well, oh, you're wondering how fast are you traveling? How fast are you traveling? Okay, so let's see what we need to find here. To find how fast I'm traveling around the Ferris wheel, that would be linear speed. Remember, the speed is, the angular speed is the rate at which the speed is changing. The linear speed is the speed. So let's go for the V formula is R times omega, and omega is 2 revolutions per minute. 2 revolutions per minute. But I need to know how about radians. 1 revolution is 2 pi radians. Now the reason I do it this way is because I want these revolutions to cancel. And I want to get then that omega is 4 pi radians per minute, per 1 minute. And so now I can go plug into the linear speed. I know the radius is 25 feet. And I know that omega is 4 pi over 1 minute. Okay, so angular speed then is 25 times 4, 100 feet, 100 pi feet per minute. It doesn't tell me the units, so I'm just going to stick with feet per minute. So 100 pi feet per minute is the speed. I'm going to get a decimal. Well, pi is 3.14, so that would be 314, right? 100 pi, 314.159, I'll say 0.16 feet per minute. That's how fast you're traveling. Oh, well, that many feet per minute could be. Because you're moving around. It's not a straight distance. You're moving around the big Ferris wheel. Okay? And remember, you were making 2 revolutions per minute. So that Ferris wheel is going pretty fast. 2 revolutions per minute. Okay. So that's an example of linear speed with a Ferris wheel. Now let's go back to the merry-go-round. Last problem. You just rode on a merry-go-round, which made 2.5 complete revolutions per minute. 2.5 revolutions per 1 minute. That's our angular speed. Your wooden horse was 20 feet from the center. 20 feet from the center. But your friend riding beside you was only 15 feet from the center. Okay, here's friend. She's 15 feet from the center. Were you and your friend traveling at the same rate? Okay, that's a great question. Well, you and your friend would be traveling at the same angular speed. So if you remember, angular speed is the revolutions per minute. And we want to get our units. We want to get rid of revolutions. So 1 revolution is 2 pi radians. So revolutions reduce, and I get 2.5 times 2, or 5 pi radians per 1 minute is the angular speed for both horses. The radius is not part of the angular speed. So are you and your friend traveling at the same rate? We are traveling at the same angular speed. Now, if you want to talk about linear speed, that would be a little different because you're in different places. Your friend is inside the Ferris wheel, so the distance, the speed there is a little different than if you're on the outer edge. You're going to be traveling at a greater radius. So the linear speed for you, which is 20 feet radius times the angular speed, 5 pi radians over 1 minute, turns out to be 100 pi feet per minute, or 314 feet per minute. I'll write that down. Then your friend is only 15 feet from the center. Same angular speed. That is 75 pi feet per minute. And let's figure out what that is. That is 235.6 feet per minute. So your linear speeds are different. You are on the outside, so you are traveling a little faster there than the inner person, but the angular speed is the same. And they didn't really specify exactly which one they were looking for, so I'm going to answer both. So this is lesson 1.1. I don't want you to get overwhelmed by all of this. It really should be 2 separate lessons, and that's why we're covering it on 2 separate days. One day this week, one day next week. So break this material up. Take your time with it. Really, get used to it. This latter part is really quite difficult, for any student. So I don't want that to overwhelm you. So hang in there, work hard. Let me know how I can help you. Have a great day.